Good morning. So our topic today is the 2020 Kentucky Pipeline Blast, which is for our PMA project. My name is Haris Kumar Alikias from Umar. Then we have Isaac Shafazil, we have Momo Adam Isnan, we have Momo Umar, we have Momo Haikal. This is our team for Group 13. Now we're going to look at the overview of the incident. So the incident is the Kentucky Pipeline incident was a major natural gas pipeline explosion that occurred on 1st August 2019 in Lincoln County, Kentucky. A 30-inch underground natural gas transmission pipeline, part of Texas Eastern Transmission System, operated by Enbridge, ruptured and exploded in the early morning hours. So basically, the rupture was caused because of leaking of gas. So the leaking of gas, the incident to happen is because there were welding failures, which caused the gas to be released into the air, and furthermore caused the blast, which reached hundreds of feet into the air. Now we will look at the chronology of the incident. At about 1:20 a.m. local time on August 1st, 2019, the line's 15 segment ruptured in a rural area of Lincoln County. The rupture released a massive volume of natural gas under high pressure. The escaping gas ignited almost immediately, producing a huge fireball with flames already reaching around 300 feet into the air that could be seen for miles. That means people from the surroundings could have seen this fire and they felt the heat, they felt the effect from this blast. Data from the pipeline control center showed the rate of change gas pressure triggered around 1:24 a.m. shortly after the rupture. The operator at the Edmonds Compressor Station reportedly saw the fire from his location. So basically, 1:20 when the gas pipeline ruptured, within 4 minutes they were notified by the data center there were changes in the pressure, which gave them alert to furthermore call the firefighters and make next actions, whereby the pipeline's remote control system and manual operations were used to isolate the rupture segment by closing blocks valves, which took about 55 minutes from the initial detection location. Then fire crews or firefighters continued battling the blaze for several hours after the explosion. The fire was gradually controlled, and by around 3:20 a.m., flames were largely extinguished. That means it took around 2 hours for the firefighters to actually put on the fire. Then the National Transportation Safety Board (NTSB) and other federal agencies launched an investigation immediately after the incident. So basically, they wanted to find the actual reason of why the pipe ruptured. Why they found that the pipe ruptured because of welding failures, which caused the gas to leak. Additional pipelines were taken out of service as a precaution and later assessed before any return of the operation. So before any operations take place, they make sure everything else was safe, other pipelines were safe, so that any blast doesn't happen anymore. Thank you. Now I'd like the groupment to continue with the next part.
Determine the handling of natural gas pipeline explosion can happen when the welding on the pipeline is poor. Weak weld can break under pressure, causing gas to leak out. Since natural gas is very flammable, the leak gas can easily catch fire and explode. This type of explosion can burn nearby land, damage roads and property, and put people's life at risk. It can injury or death, harm the environment, and result in costs for emergency response and repair.
Hi, Assalamualaikum warahmatullahi wabarakatuh. Before I start my presentation today, I will introduce myself. My name is Omar Reza bin Feroz. My metric number is TM24033 and I'm from Group 13, which is the Kentucky Pipeline Incidents. So today I will talk about the causes and OSH failures. So I will start with the causes first. So uh, the main reason is number one is the manufacturing defects. So significant grade weld defects, incomplete penetration, and lack of root, dating back to the 1950 constructions. So number two is a geotechnical loading. So basically, an active landslide create an external soil movement, so placing the pipe under extreme mechanical tension. So number three is the mechanical rupture. So basically, the weakened weld reached its breaking point because it could not support the tensile strength caused by the shifting earths. Okay, the next one is failure. Number one, failure in risk integration. So basically, the company management failed to link geohazard data, which is the landslide with pipe integrity data, well quality, and treating them as isolated risk. So number two is delay mitigation. Despite identifying the landslide risk, the company failed to install strain gauge monitoring sensor and in a timely manner. So number three is ineffective integrity management (IMP). So from there, the inspection program was insufficient for detecting legacy vulnerabilities in area prone to ground movement.
Hi, Assalamualaikum. My name is Muhammad Akmal bin Muhammad Isa. My metric number is VF23004, and I will continue this presentation with impact of the incident. Number one is human and community. For the human and community impact, this accident caused fear and stress safety concerns among people living nearby. It also forced emergency teams to step in, and some residents had to be evacuated to keep them safe. Number two is environmental. For the environmental impact, the explosion caused a big fire and the heat burned the surrounding land and vegetation. There was also a risk of gas contamination, which could harm the environment if not controlled properly. Number three is property or infrastructure. For property and infrastructure, the blast damaged the surrounding area and some nearby structures. For example, nearby buildings and facilities around the site were affected by the heat and shockwave. It also disrupted normal activities and could affect public utilities in the area, such as power supply, water lines, or road access. Next, number four, operational and financial. From the operational side, the pipeline had to be shut down, which stopped normal operation for a period of time. Financially, the company had to spend a lot on repairs, investigation, and follow up safety action. Lastly, number five, regulatory and safety. For regulatory and safety, this incident led to a federal investigation to find out the real cause and who is responsible. As a result, stricter safety checks were required, especially for all pipelines in risky areas. It also helped raise awareness about pipeline safety and the need to properly manage landslide and ground movement risks. For example, authorities now focus more on monitoring ground movement and improving inspection systems to prevent similar incidents in the future.
Hello, my name is Muhammad Tagalakimi. I will continue this presentation with the lesson learned and prevention part. The first one, I will explain the lesson learned. The reliance on initial construction quality alone is insufficient, and then the previous accident, 2019 incident, should have triggered two problem: stronger inspection and preventive action. And then emergency response costs can be extremely high. Next, welding defect can remain undetected for years. Poor welding quality can lead to catastrophic pipeline failure. And then the last one about lesson learned is a pipeline near public areas pose high safety risk. So we're going to the next slide, which is prevention. We have two parts here. The first one is welding construction. Use qualified and certified welders only. Apply proper welding procedure specification, WPS. Enforce strict welding standards and procedures. And then the next one is operation and maintenance. Implement a strong pipeline integrity management program, regular pressure testing and monitoring, update risk assessment for pipeline near the roads and residential areas. So we're going to the last slide, which is conclusion. The conclusion is the incident showed that small weld defect can cause major disaster, and maintenance essential to protect lives, the environments, and company reputation through proactive safety measure. That's all from me. Thank you.